Okay, listener name. We are diving into these excerpts you send over from Oswald CBSE Mind Maps Mathematics Standard Class X. Looks like some pretty fundamental math concepts here.
It is a bit like that, yes. Exploring those foundational building blocks of math.
Yeah. Prime numbers, formulas from geometry. We've got our expert with us to help unpack it all.
Happy to be here. It's fascinating how these basic ideas underpin so much mathematics.
It's true. And these mind maps you've got are so visually engaging. Love that.
They are great for visualizing how these concepts all connect.
For sure. So like the fundamental theorem of arithmetic.
Oh, a classic. That one's really important.
Yeah, I remember it, kinda. Something about prime numbers. They're special or something.
More like they're the atoms of the numerical world, you know? Every single number that isn't prime, we call those composite numbers, they can all be built by multiplying primes together.
So like 12 is 2 times 2 times 3, right?
Okay, you got it. And that combo, that's the only way to get to 12 using primes.
Huh. Like a fingerprint for each number.
Exactly. That's why this theorem, it's the backbone of a lot of number theory. Cryptography, coding. Even today, we're still trying to figure out those mysteries of prime numbers.
Whoa, that's heavy. Okay, but what about those formulas, though? Like in the mind maps, there's the distance formula, the section formula. Those seem more like practical.
Oh, absolutely. Your tools for navigating coordinate geometry. Think of it this way. The distance formula, it's like you're measuring how far apart 2 points are on a graph.
So if I know the coordinates, boom, I get the distance. Useful stuff.
Exactly. Now, the section formula, it's a bit trickier to picture, maybe.
Right.
Let's say you're designing, like, a website, and you need an image placed exactly 1/3 of the way down the page.
Oh, interesting.
That formula, it gives you the exact coordinates for that.
I've never thought of it that way. It's like having, what's it called, X-ray vision, but for design.
Right. You're controlling those proportions so precisely. And not just websites, graphic design, computer graphics even.
These really are more useful than I thought. Now there's this example. It's about a cylindrical glass, but it's got a hemispherical base. Feels oddly specific.
That's a really interesting point you bring up. It highlights how math lets us break down even weird shapes. By combining formulas, we figure out the volume of that whole glass.
Right, but I mean, how often do we actually see shapes like that? In real life, it's usually just a plain cylinder, right?
True, but that's where it gets interesting. Think about, like, architecture or product design. Buildings with domes, those fancy coffee cups with a curve to them.
Oh, I see. So it's more about the idea of it.
Exactly. Building a toolkit, so no matter the shape, we can calculate it.
That's actually really cool.
And this is where it gets exciting, because once you've got those basic building blocks down, you start to see the applications everywhere.
Yeah, it's like math gives us this like secret language to decode shapes and stuff.
It really is. And speaking of shapes, there's a lot about circles in these mind maps. Tangents, seconds, all that.
Yeah, I've always found those concepts kind of intimidating, to be honest.
They can seem a little daunting, yeah. But really, it's just about how lines interact with circles. A tangent, think of a line, just grazing the circle at one point.
Okay, so it just barely touches the edge.
Exactly. Now, a second, that cuts right through, hitting at 2 points.
So it's like more of a direct encounter.
I like that. And these interactions, they create some really neat geometric relationships.
So yeah, like what?
So get this. You draw a tangent to a circle, right? Then you draw a radius from the circle center to that tangent point. They'll always form a right angle.
Wait, really?
Always. Super useful for calculating distances, angles. Pops up everywhere in geometry.
Wild. Okay, I'm seeing circles in a new light now. What about those formulas for arc length and area of a sector? Those always trip me up.
Picture slicing a pie. Arc length is like you're measuring the crust along one slice. Sector area is how much pie you get in that slice.
Oh, okay, that makes more sense. So it's the same idea as the whole circle's circumference and area, but just a portion.
Precisely. Applying those concepts to parts of the shape.
Math is starting to feel less like memorizing, more like patterns in relationships.
You're getting it. Now there's this other section here, combining solids. Like cylinders, cones, spheres.
Okay, yeah.
Ever wondered how they figure out the volume of those fancy ice cream glasses? The ones that are like a cone on top of a hemisphere.
Now that you mention it, yeah, it's like they just stuck different shapes together.
It's not that different from the glass we talked about earlier, actually. Break it down into simpler shapes, use our knowledge of volumes, and we can calculate the total.
Mathematical Legos.
Exactly. And it's important because, well, we live in a 3D world. Everything around us uses those 3D shapes.
So it's useful for way more than just like geometry class.
Oh, absolutely. Architecture, engineering, even 3D printing nowadays relies on these ideas.
Wow, okay, that's way more relevant than I thought. We've covered so much. Prime numbers, circles, now 3D shapes.
And this is just the tip of the iceberg.
Mm-hmm.
The cool thing about math is it builds on itself. These concepts are just the start.
I'm realizing math isn't about just getting the right answer. It's more like exploring how it all connects, you know?
It is pretty awe-inspiring when you think about it that way.
It really is. Like, who knew that understanding circles could help us design better telescopes? That's wild.
It is incredible, right?
Yeah.
And that theorem we talked about, the fundamental theorem of arithmetic, it even helps us encrypt data on computers.
Oh, seriously?
Yeah, it's all connected. It
And
really shows the power of these abstract ideas.
it does make you see math in a whole new light.
Definitely. It's about so much more than just like memorizing formulas.
So, listener name, as you keep going on your own math journey, remember, you're not just solving for X. You're unlocking some pretty amazing secrets about how the world works.
And who knows? Maybe you'll be the one to discover some brand new connection that we haven't even thought of yet.
That's what makes it so exciting.